Welcome to Nabeel Math Academy. This is Dr. Mohammed Nabeel. In this video, we are going to study about the problems of the logarithmic function. So, how will you solve the logarithmic function equation using the properties? So, first of all, we have to know the definition of the logarithmic. So, as we know, this is a y equal log x base b. This is a logarithmic form. This is a logarithmic form. How will you convert this one into the exponential form? So I can write it as b raised to the power x. So actually this one is b raised to the power y equal x. So this is the exponential form. Exponential form. And this is what we have written here. So if the exponential form is given, how will you write the logarithmic form? So this one we can write it here, the logarithmic form. I write it. If you have y equal log x base b, I can write it this one as b power y equal x. So if the exponential form is given, how will you write this one? This is y equal, take log here, log x base b. So this is how we will write it, the exponential to logarithmic form, logarithmic to exponential form. Now we will have two types of logarithmic function. So what are they? Two types of logarithms are, there are a common logarithm, common and natural. What do you mean by common? So when you have a log x and here we say it is len x, what are the difference between these two? So here you will have a log x, here also log x, only the difference in the base. In the common log you will have a base 10, and whereas in the natural log it is base e. So whenever you will have the log base 10, we just write it log x. It means that defaultly the base has a 10. When you have a len base e, we write it that one as a len. Len means it has a base e. So this is the basic logarithmic, natural and common difference. And this is the properties you will have. So if you have a log b base b, it is 1. Log 1, the value is 0. If it is a power, I can bring this power to the front. So it is x, and since this value is equal 1 as per the 1, it is equal 1 into x, it is x. When you have a b raised to the power x, base b is equal 7. So we will solve the problem using these four properties and the logarithmic definitions. Now, the first one, you have to convert the function in terms of exponential. So you have to write it in exponential form. The given form is the logarithmic form because it has containing the log function. It is a logarithmic form. Now how will you write this one? Take the base. 8 raised to the power 2 is equal 64. Here in this one you don't have the log, therefore it is the exponential form. Now similarly here when you take it this one, as we already know, the len means it has a base e. It has a base e. Now I can write it the exponential e raised to the power 4, e raised to the power 4 equal x, equal x. Now here whenever you will have a log x only, it means that it has a base 10. It has a base 10. So I write it this one, 10 to the power 3 equal to x plus 1. So this is the exponential form. Here in this one, just you have to write it the exponential, need not to evaluate the equation. Now I write it this one, b raised to the power 3, b raised to the power 3 is equal b power 3, is equal b power 3. That's it. Now the next one, here we will have to write it in the logarithmic form. The given form is the exponential form is given. You have to write it in logarithmic form. How will you write this one? So this is the very simple. I will take the power. First write the power. So what is the power? 3 equal. I take the log here. Log 125 to the base this one. To the base this one. This is base 5. That's it. Similarly, here I can write it. How I'll write it? The power b. Take a log c base c. Log c base c. Now here I will write it the power first. Then I will write it log x plus 5 base e. Since the log base e, how will you write it? The log base e. I will write it this one as len x plus 5. That's it. Now here write the power. So what is the power here? This is the power you have. So log 5 base 5 equal, take a log here. So it is log 5, this one, and to the base b, to the base b. So this is the logarithmic to exponential, exponential to logarithmic. Here you have to evaluate this logarithm using the property. What is log 1? The log 1 value is equal 0. So whatever be the base, I don't bother about the base. Once if you will get a equal 1, so the value is 0 as per the property. When you have a same x and the base, the value is equal 1. Log 5 base 5, which is equal 1 as per the property what we studied before here. Now the next one, here the power rule. So I will bring the power first. I will bring the power first. You will get 4 times of log 3 base 3. So it is 4 times of 1. Since this value is equal 1. So log 3 base 3 is equal 1. So the answer will be 4. Now the next one, then we will have this part. When you see the property, as per the property of the log, when you have a same base, b raised to the power log x base b, when the same base, I will write it only x. It get cancelled, you will get only x. This is the property says. As per this property, since you will have a same base here, I can write it this one is equal 5. That's it. Now similarly here I can write it this one as a log e base e, because len is nothing but log base e to the power 3. I will bring the power 3 here. So what happened? 3 log e base e. Log e base e value is 1. So 3 times of 1 equal 3. Equal 3. Now the next one here. So I have to make it this one as a proper, the same base. You cannot change the base, but you can change this one, this number. So I can reverse, I can take the reciprocal. Why it will become reciprocal? Because I need 3 over 2. So here, if I write it this one, 2 over 3 to the power 3. So I will bring the power here. So what happened here? 3 times of log base 3 over 2. Here you will have a 2 over 3. So I will make it reciprocal 3 over 2 to the power minus 1. Is it the same thing? Is it the same thing? 3 over 2 to the power minus 1, it becomes 2 over 3. Why we are changing? The purpose of changing is to make it this one same. 3 over 2, 3 over 2, then only it become 1. So 2 over 3, base 3 over 2, it will not equal 1. So here we will have move it this part, minus here. When you multiply, it becomes minus 3 log 3 base 3 over 2, 3 over 2. Since the value is equal 1, so answer is minus 3. That's it. Now here log, this is base 10. 10 to the power 4 base 10. I will move it this one here. So when you multiply, 4 is already there. It is multiplied by 4. It is log 10 base 10. So log 10 base 10 is equal 1. 4 into 4, 16. Since the value is equal 1. Since this is equal 1. Then next one here we will have log base 3. I can write it this one as 3 power 4. Power 4. I will move it the 4 here. So it becomes 4 times of log. I will move it this one 3 up. So it become minus 1. 3 to the power minus 1. Now the same thing I will adjust as per the base, because the base I need the 3. So here we will have minus 4 log 3 base 3. Since log 3 base 3 is equal 1, which is equal 4. This is equal 1. Now the next rule, it is a root. So here we will have a square cube root. So if you cancel the cube root, it is to the power 1 over 3, base 6. Therefore, I will bring the 1 over 3 to the front. So what happened? So you will have 1 over 3 log, so 6 square base 6. So again power 2 I will multiply here. When you multiply this one, you will get here 2 over 3 log 6 base 6. So answer will be equal 1. Answer will be equal 1. So answer is 2 over 3 into 1, which is equals 2 over 3. 2 over 3. Now the next one, here we have log base 0.3. So how will you write this one? So this is 10 over 3 to the power 2 base 0.3. So I will bring the 2 here. So you will have 2 log. Since we need 0.3, you cannot get 0.3. 10 over 3 is 3.33. I don't get the 3.3. So 0.3. So I will make it reciprocal. 3 over 10 to the power minus 1 to the base 0.3. Now I will bring this power here. When you multiply minus 2 log 0.3. So 3 over 10 is 0.3. 0.3 base 0.3. Therefore you will get 1. So answer is minus 2. Now the next one is a very important thing. It is a domain of the logarithmic function. So what are the domain of the logarithmic function? Whenever if you see the logarithmic rule, so what the logarithmic rule says, y equal log x base b. Compulsory this value must be more than 0, strictly greater than 0. So 0 is also not included as per the definition what we see here. So this is what x is more than 0, not equal. It is strictly greater than 0. So all the things we will write it more than 0. That is my domain. So if you see this one, it is more than 0. So if you see x minus 3 more than 0, x is more than 3. So what is the domain? What is the graph here? Minus infinity to plus infinity. This is plus 3 and it is moving open to the right. So therefore domain is 3 comma infinity. So this is the domain. Now the next one, I will write it the same thing. This function must be more than 0. If you solve this one, x is more than minus 4. If I multiply both sides by minus, you will get what? X is less than 4. X is less than. If you multiply, the inequality change. Plus infinity, minus infinity, and this is 4. So here you will have to the left. The domain is minus infinity comma 4. Open. Why open? It is strictly more than 0, not equal. So here the absolute value x plus 2. So here the domain is all the real number except minus 2. If I substitute minus 2, the domain become 0. So log 0 is not possible. Therefore it must be strictly more than 0. Therefore the domain is minus infinity minus 2 union minus 2 comma infinity, or in other term we can say all the real line except minus 2 whenever you will have absolute. Now the next one we will have here, this one is more than 0. X minus x square minus 4 more than 0. This is a quadratic polynomial inequality. How will you solve? This is the factoring. So 2x minus 2, x plus 2 more than 0. What is the critical value? X equals to x equal minus 2. Now what is the sign diagram here? Plus infinity, minus infinity. This is minus 2, this is plus 2. When you see this one, how the here x positive, plus into plus, it is plus. The sign, I will check only the sign. X is plus, plus into plus, which is plus. After that, alternate sign. What is the alternate sign? Minus. Alternate sign, it is plus. What we need here, I need more than. More than, you will have what? Two interval. What are that two interval? And this is one of the interval and this is another interval. So I will write it the domain minus infinity minus 2 union 2 comma infinity. Both are open. Now the next one, it is also the same thing. It is a quadratic function expression. You have x square plus 10, 7x plus 10 is more than 0. Is it right? So how will you solve this one? Polynomial inequality, factoring x plus 2, x plus 5 is more than 0. What is the critical value? Minus 2, x equal minus 5. What is the sign diagram? Plus infinity, minus infinity. This is minus 5 will be first, minus 2 will be the second. Now what is the sign of x? The sign is plus here. The sign of x is plus. Plus into plus, it is start with the plus. After that, alternate sign. What is the alternate sign? Minus, here plus. Since we know here, we need here more than. More than means you will have a two interval. What are the intervals? You will get 0 minus infinity comma minus 5 union minus 2 comma plus infinity. This is the interval. Now the next one here we will have more than. This is also more than. 4 minus x square more than 0. Therefore, you will get x minus 2, x plus 2. As usual, the factoring. What is the critical value? Here x is equals to, x is equals minus 2. Now, I draw the sign diagram. Minus infinity to plus infinity. Therefore, here minus 2. Therefore, here it is plus 2. Now when you see the sign, here it become plus, the x coefficient, and here it is minus. When you multiply plus into minus, starting will be minus. Starting will be minus. Then alternate sign. What happened? Plus, here minus. We need here more than. More than means only one interval, that is you will have in between plus and minus 2. So the domain is minus 2 comma plus 2. That's it. Now the next one, it is a x log x over x minus 8. So I have to find the domain of the function. So when you take x minus x over x minus 8 is more than 0. This is a rational inequality. Find the critical value. Critical value is 0 and 8. And the sign diagram plus infinity minus infinity. This is 0. This is 8. Now when you see the sign of x, x is plus here, x is plus here, starting will be plus. Now alternate sign minus, here plus. We need here more than. More than means you will have a two interval. What are the two interval? This one and this one. Now what is the domain? Domain is minus infinity comma 0 union 8 comma plus infinity. 8 comma plus infinity. Then h of x is equal log x over 8 minus x. Find the domain of the function. So I have to write it. This one is more than 0. This must be more than 0. X over x minus 8 more than 0. What is the critical value? X equals 0. X equal 8 is the critical value. Now what is the sign diagram? Plus infinity, minus infinity. This is 0 and this is 8. Now what is the sign? X is plus, here minus. Therefore, I will start with the minus, then opposite sign. It is plus, then minus. So you will have here, you will have this one, the more than, strictly more than. More than means what? More than here, greater than So what is the only one interval which is in between 0 and 8? Therefore, the domain is 0, comma 8. So this is the domain. Now, here you will have a function x square over x minus 4. So this value must be, this expression must be more than 0. Then only the logarithmic is exist. Now if you see this one, x value, put it numerator 0, it is 2 zeros because it is repeated. Now you will have x is equal 4. Now if you see this one, plus infinity, minus infinity, and here it is 0 and here it is plus. Now when you see the plus with the plus, it is what? Plus, then minus, and here minus. Why it is not changed? Because this value is repeated. Whenever there is a repeated critical value, there is no sign change. So there is no sign change if you have a repeated critical value. So you will have more than only one interval. What is that interval? What is that interval? You will have 0 to, that is 4 to infinity. So domain is 4 comma infinity. That's it. Now the next one, here we will have a root. So how will you solve the root? So first of all, we will use the property of log. So what is the property of log? So if I cancel the root, it is to the power half. So as per the property, I can bring this half to the numerator. So it becomes 1 over 2. Then you will have log x minus 11 base 3. So therefore it is, we have to write it, this one is strictly more than 0. So what is strictly more than 0? X minus 1 more than 0. X is more than 11. Therefore the domain is minus infinity to plus infinity. This is 11 and it is going to the right. Therefore the domain is 11 comma plus infinity. Similarly this one you will have the root. So I will use the property first. So the property is gives here, this is log of 2x minus 11 to the power 2 power 4. So I will bring this power here. So what happened? This is h of x is equal 1 over 2 log of 2x minus 11 base 4. Now this term must be more than 0. So 2x minus 11 more than 0. X is more than 11. X is more than 11 over 2. So if you draw the graph of this plus infinity to minus infinity, this is 11 over 2. It is right open. So it is right open. So therefore the domain is 11 over 2 comma infinity.